Salam and welcome everybody. Today's lesson is about how to prepare aldehyde and ketones chemically or in the science lab. So the first thing that you have to put in your mind, we're going to start with aldehyde for sure. The aldehydes are made by oxidation of primary alcohols. Okay, so how can I describe that in terms of real equation? So let's start with a normal, let's say alcohol. Let's take methanol, for example, CH3, CH2, OH. And as we can see here, the methanol is a primary alcohol since the OH group, which is called hydroxyl group, is bonded to carbon. And this carbon is bonded only to one alkyl group in here. And that's why it's primary. We're going to oxidize the primary alcohol by adding acidified KMnO4, okay, or acidified K2CR2O7, which is called potassium dichromate, and this is called potassium manganate. So both work as oxidizing agents. We just want to recall the oxidizing agents. They are being reduced and they oxidize the other atoms or other species. So these materials like KMnO4 or potassium dichromate will oxidize the alcohol. And as we notice that the alcohol here is primary. So as a result of this process, we will notice the presence, or let's say the changing of CH2OH into carbonyl compound, and it will appear like CH3. This group, as we can see, look at this, CH2OH will change to C double bond H. Our compound is aldehyde, and it has the name of ethanol. All right. So we can get the aldehyde by the oxidation of primary alcohol. Put in your mind, if you just make further oxidation for the aldehyde by applying more acidified K2CR2O7, all right, in the presence of heat, it will oxidize furthermore to carboxylic acid, and it will change to CH3, C double bond O, OH. So this is the carboxylic acid group. Perfect. But I have a question. If you look at this group in here, which is aldehyde, and here, which is alcohol, according to what we learned before, we just noticed that the alcohols have the hydrogen bonding. Okay, hydrogen bonding. And we just remember that the hydrogen bonding is the strongest intermolecular forces. Okay. And that's why it will be reflected on its boiling point. It will have higher boiling point. But higher than what? If we go for here, which is aldehyde, and we just write it in here, CH3, C double bond, O and H. So if I ask you what is the type of intermolecular forces that you have here, you could say, is it permanent? Is it temporary? Is it hydrogen bonding? First of all, you just notice that you have difference in electronegativity because you have electronegative atom, which is oxygen, and it's partially negative. And here you have carbon, which is partially positive. As a result of this difference, it leads to make a difference in electronegativity, and thus you will have a permanent dipole interactions, or let's say intermolecular forces. But in this compound, we don't have the hydrogen bonding. Thus, the boiling point of aldehyde, okay, I mean like the same number of atoms, it will be less than the boiling point of alcohols. And this belongs to the intermolecular forces because we have stronger intermolecular forces, stronger attractions, and thus need more energy is needed to overcome these attraction. Okay, another thing to put in your mind, Suppose that you're gonna take this material before changing it to carboxylic acid. How can I take the aldehyde from my vessel or C2? We can take, or let's say, separate aldehyde by distillation. And we can make a distillation process in here because we have differences in the boiling points. So we can separate the aldehyde in terms of fractional distillation. Perfect. Now we can prepare aldehydes from alcohol. And now, guys, let's go back again. If we have K2 Cr2O7, as we told you before, it works as an oxidizing agent because it oxidizes the other atoms. So if I ask you to calculate the oxidation number of a chromium atom, you will find it plus 6. How to find the oxidation number in terms of calculations? We can say we have 2, which means 2 potassium atoms. The oxidation number of potassium is 1, according to the oxidation rules. Here we have 2 chromium atoms. We have 2 times Cr, which is unknown oxidation number, and we just noticed that we have 7 oxygens, and oxidation number of oxygen is -2, and the answer here is 0 because we have 0 overall charge. Okay. After doing some calculations, you will notice that it's plus 6. Another thing to put in your mind, once you use the potassium dichromate, it has a color of orange. Okay, I just want to write it well, orange. And the orange color belongs to chromium 6, okay, or chromium plus 6, which is the oxidation number. As we told you, the chromium in here works as an oxidizing agent, but it's being reduced. So according to the definition of reduction, we're consider the decrease in the oxidation number of chromium. And actually this is true because chromium will change to chromium plus 3. And chromium plus 3 has a color of a green, okay? It's a green. So the observation that you will notice once you make oxidation process of alcohols to aldehydes or alcohols to ketones, you will notice that the changing from orange to green. Okay. Another thing to put in your mind, which is very important, once you talk about chromium, chromium is a transition element. Okay, it's a transition metal. And the transition metals are inorganic metals. Okay, so the color change, it's not as a result of organic material. It's only as a result of inorganic material. Another thing to discuss, if I ask you to describe the oxidation of ethanol to aldehyde in terms of oxidizing agent, which is oxygen between square bracket, how can I deal with such equation? First of all, you will write the alcohol, CH3, CH2, OH, and you will add plus, you add oxygen. The oxygen in this case refers to the oxidation process, okay? And then you will notice that you will have aldehyde because this is the first step of oxidation. You will have CH3, C double bond O, and H, in addition to water molecule in here. Okay, so what to do in this case? You have equation, and this equation must be balanced, okay? It must be balanced. How can I balance this equation? First of all, you have the same number of carbons. Yeah, we have 2 carbons. How many hydrogens do we have? We have 1, 2, 3, 4, 5, 6. We have 6 hydrogens. And here we have 2, and here we have 1 and 3. Then it's 6 hydrogens. Perfect. What about oxygens? Here we have 1 oxygen, and this is 2. Okay, and here we have 1 oxygen, and this is 2. Then my equation is balanced. And let's start with the second part of the carbonyl compounds. In the previous video, we talked about the preparation of aldehydes. So how can I prepare ketone in a chemical mean? So first of all, we're just going to remember what is the ketone. The ketone is an organic compound that contains a double bond between 2 R groups, which are alkyl groups. So how can I prepare such a compound? The general informations, or let's say the general idea that we can prepare the ketones is from secondary alcohols. So once you have the secondary alcohols, you just make oxidation process, then you will have ketone. Okay. So what is the oxidizing agent? How can I, or let's say, is it possible to oxidize the ketones furthermore like aldehydes? Let's start. So the first thing here, we're going to start with a normal, let's say, secondary alcohol, and let's take CH3, CH, OH, and here we have CH3. So the oxidizing agent that we're gonna use is acidified potassium dichromate, which is K2Cr2O7. And we just want to remind you the oxidation number of the chromium here is +6. And the whole compound here is orange. All right. The conditions, as we can see, you must add acidified KMnO4 in the presence of heat as well. Okay. And most likely the most, let's say, used acid is sulfuric acid, in this case, H2SO4. But in general, we can describe it in terms of acidified by H+. The product that we're going to have is ketone. So this compound, which means that the CH that contains OH group will change to, I just want to write it in terms of, let's say a little bit, display formula. Look at this. The carbon that has OH group, okay, will change to carbonyl group. And then you have C double bond O, and here we have CH3 and CH3. So in this case, this is ketone, and it's called propanone. You have 3 groups, and this is propanone. Okay. And in addition to water molecule, because we just get rid of water and we have oxidizing agent in here. Okay. How can I describe this equation in terms of the simple? You can write that in terms of CH3, CH, you have OH in here, and then you have CH3 plus O, and then you have CH3, CO, CH3 plus H2O. So the number now is counting the oxygens. Here we have 1 oxygen, and here we have 1 oxygen in the reactants, which is good. And here we have 1 oxygen, and here we have 1 oxygen, which is the same in this case. And we have 3 carbons, we have 3 carbons, we have 8 hydrogens, we have 8 hydrogens, and here we have 8 hydrogens. We have 2 from here and 6 from here, then this is balanced. The observation in this case, well, changing the orange color to green. And this is as a result of changing the oxidation number of a chromium from +6 to chromium +3. The chromium +3 appears as green. And put in your mind, this double in here, and you have here orange. Put in your mind, the chromium is not organic compound. Okay, this is inorganic. This is a transition metal, and that's why we don't consider it as organic compound. What you have to put in your mind in this case, this is the ketone. If you apply more heat and add more acidified potassium dichromate, you won't be able to oxidize it. So you can't oxidize the ketone furthermore like aldehydes. Another question to put in your mind, do we consider the potassium dichromate, I mean acidified, the only oxidizing agents to oxidize primary or secondary alcohols to change them to ketones and aldehydes? No, the answer is no. We have another good oxidizing agent, which is acidified KMnO4, which is potassium manganate, and it has the same rule as the dichromate.